Hello, and welcome to the podcast. Steve here, and Bill's not with me today. So this is another bonus episode, similar to what we did with the Christmas bird count. This recording was done right at the end of December 2016, but it's still pretty relevant for early March. I was joined by Matt from In Defense of Plants and Sara from Midwest Explorer. We were hiking at Hunter's Creek, one of our favorite spots in western New York, and there was plenty of interesting things that we stumbled across, but we did have two loose objectives for the recording. Number one, identify trees by their bark, and number two, get down to a small creekside stand of American Sycamore trees. But right now, I'm in Buffalo, New York, on my way to a massive American sycamore on Franklin Street. This tree is thought to be the oldest tree in Buffalo. Back in the 1960s, it was estimated to be 250 years old, which would make it over 300 years old today. So I had to do a little skeptical inquiry on that, but I'll talk about that a little more at the end of the episode. I also want to say that recording and editing these episodes is always a challenge, especially in post-production. Recording on the trail is a double-edged sword in a lot of ways. It gives us the great sounds of the nature around us, and it gives us unexpected topics we could focus on as we stumble across them. But there's also a decrease in the audio quality that you really wouldn't get if you recorded from in a studio. I think most of you guys understand that, but I just wanted to say it because this episode was especially challenging, and I blame Matt because he wandered away so often. Because we talked about so many topics in this episode, for your convenience, I listed them all in the episode notes, with appropriate timestamps and supporting links. We also provide a picture album on our Facebook that contains many of the species we saw during the hike, so feel free to check that out, either while you're listening or afterwards. Okay, and without further ado, here's Matt, Sara, and myself talking about tree bark, amongst other things, at Hunter's Creek Park.
Hello and welcome to the Field Guides. I'm Matt, and I'm here with Sara.
Hello.
And Steve.
You know, I told you this wasn't going to be an episode of the Field Guides, am I right?
I don't listen to you.
Yeah, give me the mic.
Okay.
Okay, I finally got the mic away from Matt.
You wrestled it away.
All right, Sara, tell us what we're doing.
We're going to be hiking around Hunter's Creek today, seeing what we see, and on our hike, hopefully trying to identify some winter trees, as well as looking at bark characteristics.
Yeah, and talk about anything that we think is interesting.
Sara already found something really cool.
Looks like she's playing with a pupa.
Disgusting.
Found a pupa.
I thought it was
hairy
a turd.
pupa.
I thought Sara was playing with poop again.
It looks like it was in the stages of
Dormancy?
liquefying.
Yeah.
Oh, yeah. You said there was a hole in it?
There was. It was like up near the head region.
The tomato hornworm also has a pupa like that, and this looks similar. Do you guys think it might be?
I mean, it was definitely on the ground. I don't know. It looks like it was definitely attacked by a fungus, though, because everywhere there's like a abdominal segment is got white stuff coming out of it.
Got a lot of hairs.
It's not alive.
Well, we should also say where we are right now.
Oh, yeah. We're at Hunter's Creek, one of my favorite hiking spots in western New York.
We should also say that Matt and Sara don't live in New York. They're not going to be regular guests, but this is sort of a special episode because we have them back, and it's nice to have them back.
It's great to be back in the northeastern forest region where there's topography and a lot of glacial legacies.
What's that plant? With the thorns.
It's definitely a rose.
What are you looking at?
This stalk right here.
If there's leaves on it, we can tell.
So it got the stipules.
Yeah, that's what I'm looking for.
You're a stipule junkie.
Yeah.
Here, this is actually the same plant too.
Do you see the leaf on it?
Yeah.
And there's no stipules.
No stipules.
This isn't multiflora rose then. So
Rubus.
The multiflora rose has almost a comb-like stipule. It's a long comb-like stipule on the base of the leaf.
I never noticed it until you posted those really good pictures of it.
Yeah, I am really good. Is that what you said?
I'm really good.
This is it though.
Yeah.
Look at that.
Too far from.
That's definitely most.
Oh yeah, without a doubt.
Oh, and some of it is still bright green.
They stay green for a lot longer.
They leaf out earlier in the spring and they keep their leaves longer in the fall.
Hey, look, willow herb.
What is it? It begins with an E, right?
Epilobium?
Epilobium.
It could have changed, honestly, but there's still seeds. I love how the seeds are arranged.
So epilobium's beautiful because when the seed pods bust open, how would you describe that?
I mean, it's dehiscent.
Matt just used a fancy word called dehiscent. That means the seed pods are dry.
They dry, and then as they dry, the cells tighten, and it peels back like a banana peel almost.
Yeah, like a cartoon banana, just totally split open.
So there's like a central spike in the middle that I think contained the ovules, or at least was the attachment point for the ovules, but then there's a 4-part chamber that was protecting them, and that peels back like the cartoony banana peel. But the way the seeds are arranged, it's actually really beautiful, especially if you look up top like this. And the only way I can describe it is like the first split second when a net gun gets fired in a movie. Like, look at it from here.
Yeah, so the net gun, it kind of starts as one rod, and then it splits, the rod splits into many little rods with a net connecting all of them.
Out.
Right.
Yeah, so the seeds are connected at the base in that center.
Oh yeah, we have some seeds right there.
But then they have, I guess you'd call them like achenes.
And a keen is just going to be a single seed, and it's usually attached to the seed coating by a single point.
And without a hand lens, I really can't say.
So you'd imagine that this would be wind dispersed.
Anemochore is the technical term.
Really? So chore has something to do with dispersal?
Yeah, so like Myrmecochore and Lyriochore, which...
The ant one?
Myrmecochore is the ant one. Lyriochore is bird nest dispersal.
Oh, bird nest, right. Just as a very, very brief introduction to what these flowers look like, there's 4 petals that are fused together, and they're all split down the middle.
Typical of the pink family, Caryophyllaceae.
But they are longer flowers, right? They're sort of tube flowers,
tubular.
and they just flare out at the end into 4 separate petals.
Do you know why they're called the pink family? It has to do with those petals, and it's not the color.
Pinking shears. I forgot I had actually looked that up.
So the pinking shears put the little divot, and all of the pinks, or at least most of them, have the little divot in their petals.
Yeah, that's so cool.
It makes it look like they have twice as many petals.
It's like, why are there so many white pink family flowers?
I was really upset by it first, and then it comes to find out I think the color was actually named after the flower. So like the color in and of itself all comes back to like the flower was named after the shears, but then the color was also named after the plants. So it's like pink is just this meta color.
Hey, wait, time to quiz Matt. Because I know you do listen to our episodes. So what makes the Caryophyllaceae... I can't... You know what? I'm not bad with orders. I cannot say the pink order. Let's say, what's special about the pink order, not including the Caryophyllaceae? And I think there's at least one other family that this doesn't include. Think about the flowers. That'll be your hint. Think about the color of the flowers. That'll be your other hint.
They're mostly white?
Nope. I'm talking about the betalains.
It's specific pigment, right?
Yeah, so that order doesn't have... Anthocyanins. Yeah.
Right, it's a unique subset.
Yeah. So we had actually done a whole episode on that. The pink order doesn't have anthocyanins. They have another type of pigment for their reds and blues and whatnot. That's the betalains. Except the pink family within that order, they actually do have anthocyanins.
Yeah.
So, yeah.
Right down there, do you notice that all those little tracks leading to that hole in the side of the drumlin there?
Oh,
or not drumlin, I guess that would be a moraine.
What do you think it is?
I'm going to guess fox.
You should go smell it.
That is a really treacherous hike down, and I'm not going to do that, so...
Whoa, okay. Here's musselwood.
Right.
And musselwood's one of the ones that we could tell by the bark, but it's still holding onto its leaves, and I didn't realize that that was one of the species that did that.
I didn't either, but considering it's in the same family as oaks and beech,
right,
it makes sense that it might hold on to them a little longer, but this is pretty extreme, actually. I think every musselwood, or every tree we're seeing right now, with the exception of like 2 or 3 that's holding onto its leaves, is a musselwood.
Which is the same as hop hornbeam, correct?
American hornbeam is musselwood, and then hop hornbeam is what they call ironwood.
Learning all the time.
Yeah. Common names are the worst, and I don't know the scientific name.
Yeah, to be honest with you, I don't either.
Common names are maybe the least interesting part of the tree.
I think the important part about this identification is the fact that we looked at the bark for it.
We didn't even talk about what the bark was.
Yeah, it is very smooth, very muscly.
It's sort of sinewy like muscle.
Yeah, exactly. Yeah. So it's got these weird ripples in it, and it kind of looks like a bodybuilder, but not nearly as disgusting.
The lankiest bodybuilder.
Yes.
Skinniest bodybuilder in the
world. The most photosynthetic bodybuilder ever. It does have some striations, like vertical striations, but it's not a color thing. It's actually splitting of the bark. Because fun fact, trees are a lot like insects in the fact that they grow a lot faster than their outer shell, so to speak, in this case bark, can actually keep up. So the splitting is actual physical splitting from the interior of the tree growing faster than the bark can keep up with it.
So is that the same thing we would see in like a striped maple?
Yeah. So it's the tree outpacing, or at least the cambium outpacing what the bark can grow. But as the bark splits, you get the secondary layer that kind of comes in to fill it in. So it's never truly exposed. It's not like its own worst enemy.
That's awesome. I had no idea that that's why those patterns emerged on the bark like that.
Hey, speak of El Diablo.
The Spanish devil.
Yes, because we found ourselves a hop hornbeam.
We were saying before that musselwood, also called American hornbeam, but American hop hornbeam, whatever. It's just a common
definitely
name.
American.
It's a free tree.
So even though they have sort of similar sounding names, the bark is very different. This bark is sort of in vertical stripes. It kind of peels off
Literally
a little bit.
strips, yeah.
It's almost like a shagbark hickory in a sense, where it peels back, but it's a very reduced.
Right.
It's a very neat looking tree, but every now and then you get some peeled bark.
It gets way peelier up at the top. The reason it's called hop hornbeam is the infructescence of it. The fruiting bodies look a lot like hops.
Oh,
Yeah.
okay.
So sort of these seeds in like a bladdery sort of sheath.
Well, I'm glad we saw musclewood and ironwood as well. I think that there's a lot of overlap with those common names too. So,
Right.
yeah, I think American
lies the
hop
issue.
hornbeam is the best. Yeah,
Yeah. Cool.
cool. I'm
Great
glad we
tree.
saw it.
So here's another really characteristic one, and I like this particular individual because it is a...
Black
it's a black
cherry.
cherry. I like black cherries because it's different points of their lives. They look drastically different from one another. So when they're young,
Right.
their bark is very smooth, and it's got very pronounced lenticels.
Here you can see the lenticels
Yeah,
pretty well.
so this is a really cool transition area. It's just young enough that you can still see the younger bark characteristics, but it's starting to get that older burnt cornflake look of a black cherry.
I was about to ask if you remembered the way that at least Sandy taught our class.
So you can picture what a burnt cornflake or potato chips. They're not necessarily uniform, but you get these little chunks that
Just
kind of flake off.
A weird arts and craft experiment.
Yeah.
Burnt potato chips all over a tree.
But as far as maturing go, they're like the exact opposite of what you'd expect. But at this one, you can still see the lenticels. They're horizontal holes, essentially.
They're for oxygen.
Yeah,
or
gas
oxygen
exchange.
Gas
Yeah.
exchange.
Which gases are exchanged?
Anything that would be in the
Yeah.
air. So nitrogen, oxygen, carbon dioxide. But then for what's released, it's going to be mostly oxygen and a little bit of CO2.
Right.
Nitrogen as well, I guess. You would imagine that eventually, at a certain point, lenticels aren't doing their
Yeah.
duty anymore. And I think at this point, I don't think...
I'm going to say these are non-functional because you can actually see under some of these like flakes here, like those have lenticels and there's nothing attaching
Right,
that part to the
exactly.
tree.
If it's not attached to anything, the lenticels can't be doing anything. And another thing that I think would be interesting to talk about, so even if they were still functional, they would be a lot less functional right now because in the wintertime, trees are much slower growing. And I'm sure Matt can confirm this, but that's the reason you get rings in trees.
Right. When things start to slow down, they start producing a different kind of vascular tissue, which is a lot tighter.
Which gives the illusion of rings.
Right. It is actually continuous vascular tissue. There's
Yeah,
never a point in which it just stops.
The tree is always growing, but in the winter, it's just growing a lot more slowly, and so these rings look tighter, and that's what makes the look of the ring when you chop a tree down.
Right. I do think it does, especially for northern hardwoods, it does stop eventually. After, I think it's like 2 degrees Celsius is about the minimum I think I've read for trees. But it's never like stop and then a wall goes up. In fact, in the tropics, where it's continual growth, you generally don't get rings. Or you will get seasonal rings, but you really can't judge age of a tree that way.
All right, so what do we got here?
Well, we have 2 really great trees side by side. The first one we noticed was the downy serviceberry. Much smaller, but kind of maxing out for what I recognize as like a mature downy serviceberry.
What's the larger group that the serviceberries are part of?
They're related to apples, Rosaceae, essentially. Yeah. But this one, I mean, they're very characteristic if you know what you're looking for. At least the downy serviceberry, it's got these vertical striations on the bark, again arising because of that rapidity, sure. Rapidity of the growth in relation to what the bark can handle.
Yeah, and I'm really glad we saw this one immediately after talking about the tree outgrowing the outermost bark.
Yeah, because this is really
obvious stretch marks.
Serviceberry is one of the trees that when you look at, it has a very smooth bark, but it has these vertical stripes that are kind of swirling around the tree somewhat, like they're kind of going at a slight angle.
Yeah.
I think when I first learned about them, I was like, is this a gigantic striped maple? Because you don't see big striped maples.
Exactly.
At least I've never seen it.
I looked up the champion striped maple, and it is a massive tree. In fact, I think I'd probably walk by and go, there's no way you are what that is.
No way.
I don't remember the exact specifications. We can probably look it up on American Forests, because if you want to see the massive tree registry for the United States, that's the site to go to. But generally, a lot less green.
The striped maple has some greens and blues.
Yeah, very colorful bark, whereas this one's a little bit more of like a nice bluish-gray tone.
Do you remember if the moosewood or striped maple is actually photosynthetic bark? Is that why there's green in it?
I think so.
I'm pretty positive I read that about it.
Oh, I think that dog is cueing in on the den we found.
Oh, yeah, I think it probably picked up on that scent. So any more about the serviceberry? Oh, yeah, the tree next to it.
So there's the tree next to it, which is a red maple.
I was going to ask about the maple. Do you see a leaf growing right out of the side?
Yeah, right here.
What's that called? Is that all it's called is a side bud? When you have a single leaf sticking out of the side of the tree?
It definitely has a technical term.
It's just something the tree does from time to time.
It's a dormant bud sitting on the side of the tree, which probably, if the forest got leveled around, it could turn into a side branch to pick up more light, but
Right.
this is a pretty closed canopy at this point.
What screams maple to you?
So the funny thing is this one's not really showing it.
It's got a reptilian skin-ish
Like the
kind of pattern.
belly of an alligator.
Yeah.
Right, so kind
But
of
this
like
doesn't have that.
squirrel sort of barking, but anytime you get furrowed bark like this, you tend to get really great little microclimates, and this tree is hiding one of my favorite epiphytic liverworts in the genus Frulania. So yeah, I'm not even going to guess which species this is, but Frulania is an awesome little epiphytic liverwort, and it just seems to like, furrowed bark because you can get little moist microclimates, and yeah, it's just really tiny, so you have to work to appreciate it.
What says Frulania to you? I know nothing about liverworts or any...
Yeah, now you're going to take me to task on some specific things, other than the gestalt of it all, but
Right.
It's very small, it's very narrow, it's got overlapping leaflets, or whatever you want to call these, they're flaps.
So if you have a hand lens, you could see them
Yeah,
pretty
totally, and they overlap kind of like shingles on a roof, and they're not like too wide, it's just alternating one-on-one, and then just the red anthocyanin pigments are really characteristic of it in that group. And then, like you said, process of elimination, it's not radula, because radula is much larger and green, and there's a handful of others that are much bigger than it, and a lot that are probably even much smaller than it. So it's just kind of, and the way it forms these kind of, I don't want to, this one's a really bad example of that, but it kind of does form these concentric ring colonies. So it starts, obviously there is one nucleus site where it started, and then the colony kind of builds out. And generally when you see a big older patch of them, they're circular.
It has like a nice branching pattern to it.
Yeah, it is amazing. And it's just one of those,
Easy to walk by.
Yeah, very easy. In fact, I remember the first time I noticed them and took a hand lens to them, it kind of changed my life in like a very specific way. But now I pay attention to liverworts a lot more. Hey, look! We were talking about reptilian bark. There's a nice red maple with exactly what we were talking about.
Yeah, this is exactly what I think of when I think of red maple bark.
And you know what? In retrospect now, I think it has to do with the age of the tree, because even notice this one's got a lot more smooth. It's younger.
I was going to ask if that's what you were thinking. That was
Yeah,
younger.
so I think what ends up happening is red maples start off very smooth, which you can see up higher on the tree.
Oh, there's patches of smoothness all
very
up this guy.
almost like beach smooth.
Yeah.
But you can see it's cool because there's the patches of smooth that get more numerous at the top, but as you come farther down towards the base of the tree, you can actually see the bark is physically splitting. It almost looks like it like you can see the tension building. And when the bark starts to mature, not quite antiqued yet, but starts to mature, you get that characteristic reptilian belly, crocodile belly.
Yeah, it's interesting the way this bark splits like that, because not a lot of barks do that.
I think it's definitely worth mentioning that bark, and in general, is not a very specific term. It just kind of encompasses all the coating of really woody species.
It gives you enough to work off of.
Wood in and of itself has evolved independently multiple times, so it's not even like there was one origin of it and they've all diverged from one common ancestor. It has independently evolved numerous times.
You're saying that trait,
a woody trait, has evolved numerous times, going from herbaceous tissue to woody tissue.
Right, so the ancestor of many of these trees wouldn't have had a bark that they all have today. Many of these barks evolved later.
And individual lineages, and that's why, part of the reason why we probably see such a wide variety of forms and functions. It must be something good if forests are this big.
Yeah.
Exercise in evolutionary arms races.
And speaking of evolution, we talked about beech and oak earlier, and we actually have a bunch of beech very close to us right now, just within sight. So this is what we were talking about before with the musselwood, that even though they're deciduous, the leaves stick around, and they only fall off when new leaves start growing in the spring. Quiz number 2. You failed the first quiz. So if you're not evergreen, and if you're not deciduous, what are you?
Confused.
So, it's marcescent.
Marcescent.
Yeah, so marcescent trees like oaks and beeches, they're trees that have only migrated up north relatively recently in terms of their evolution, and so they don't drop their leaves as well as trees that are more used to this climate.
But they're not holding on to them as like a photosynthetic leaf.
Right, it already reabsorbed its photosynthetic.
The leaves are effectively dead.
Right, so I haven't done much research into this, but I have to imagine that there would be some downside to holding onto these leaves, because it seems like the snow would catch the leaves a little bit better, and you should expect more damage on trees like that, but you see beeches everywhere, you see oaks everywhere. Maybe their branches are strong enough, or maybe they recover from the breaking.
I've read, too, that the research shows that the younger trees tend to do it more, where I would feel like snow weight wouldn't be, they'd be more pliable than an older tree.
Right.
When I look around, it's holding to that anecdotally at least, to that pattern, all the younger beech are holding on to way more leaves than the older ones. My favorite theory, personally, is anti-herbivory, although there's plenty of different theories on this, and no one really knows why.
Is it because the leaves kind of make noise when they
make noise,
shake?
But also, if you're a hungry deer and there's really nothing living left in the leaves, it's a lot of wasteful tissue that you can't digest. So I feel like if for every bud you get, you're getting 20, 30 leaves in a mouthful, it's not worth your time. So when they're at convenient nibbling height for deer and moose, who knows?
That's interesting.
Yeah.
I didn't know about that. Okay, guys, so before we move on, let's just say what our...
We do have a
sort of a goal. Yeah.
Pseudo-objective. We're looking for sycamore.
So I guess there's a stand of sycamore a little bit further down this path.
Right. Being a riparian specialist, though not obligate by any means, we're heading to the lowland area, the floodplain of, I think this is Buffalo Creek, or a tributary of Buffalo Creek, where we can hope to see some sycamore, because there's a lot of cool things to say about sycamore and their very characteristic bark.
Yeah.
But I'm super excited, mostly because we're heading into a stand of hemlock. I live in Illinois, which is just outside of the range for a majority of the state, and the fact that I work in North Carolina, where most of the trees, these trees have died, unfortunately.
So we've made it down to the water's edge. We're in a nice stand of hemlocks.
And we have a birch, a yellow birch, too.
Yellow birch, too, another great tree.
Yeah, related to the beech.
Yeah, and this one's...
Beech and oaks.
This one's got a different kind of smooth bark.
Yeah, it's in horizontal stripes.
Right, and it peels that way, too, so it gets very peely. Well, for most of its life, they don't start to look more like traditional bark trees until they're a lot older, but these lenticels are still functional.
This is another tree that has very obvious lenticels.
Yeah, and this nice golden bronzy color, very characteristic of this tree. And this gives you the oil of wintergreen.
They're one of our three main hardwoods that we have in the Northeast.
Yeah.
The maples, the beeches, and the birches. I guess the hemlock would be the fourth, but that would be more of a softwood associate.
It's just really nice to see a healthy stand of hemlock. The hemlock woolly adelgid, which was introduced from Asia, has totally wiped them out in warmer areas where winter kill doesn't knock the insects back. But as climate starts to warm and warmer areas move farther north and we get more mild winters, that's probably going to change, which is really upsetting.
One of the things I really like doing in the wintertime that hopefully as time goes by we'll still be able to do is that a lot of the conifers, it's really fun to look through their needles, because you'll find little spiders in there and you'll find little insects.
Yeah.
Actually, you could see something right
there,
right here.
Yeah.
It's completely curved the leaf back.
Yeah.
And it's a big mass.
But then look at here, there's a little egg sac dangling. That's the one I was initially.
Oh, yeah. I mean, if you think about it, if you bunch a few needles together, that's a pretty good protection from wind and snow and whatever
else.
else.
All winter.
Yeah.
Yeah.
Oh, I love them. There was a bird that had pooped from this tree, because there's a bright purple poop on the ground.
Oh, holy cow.
See it?
That's super.
It's really purple.
What do you think it was eating?
Could be
buckthorn?
Pokeweed.
You think?
Could
Purple,
be.
though?
I don't know. Could be.
Could be pokeweed.
There's a lot of privet around here, too.
Privet, yeah.
So
that's the non-native that we have in the East.
Yeah.
It's funny, you hear people talk about privet, but a lot of the places that I hike, I don't really see very much. 18 Mile Creek definitely has it a bit.
It's definitely in certain areas, but that's a good point. I mean, invasive species aren't going to be invasive everywhere.
What is that bark? I don't know that bark.
That is big-tooth aspen. Doesn't get nearly the attention that its cousin, the quaking aspen, gets.
That is such cool bark.
Horizontal rings at the base, graduating up into what you would consider as the nice white, smooth bark of an aspen.
I've seen big-tooth aspen before, but I've never seen this bark on it.
This is a nice intermediate stage, because when it does get older, it gets much more scraggly at the base, and you really have to look towards the tips of the branches to see that white bark.
So the aspens are closely related to the cottonwoods. I think they're all populous, right?
Yeah.
But even the cottonwood sometimes has that smooth bark that you would associate with the aspen.
Yeah, up on the younger tissues.
Up near the tops of the trees if you look closely.
Right. Yeah, I love the big-tooth aspen. I think it's got one of the most attractive leaves of any of the trees, and again, they just don't get the attention. They're generally very fast-growing trees and have sacrificed durability for fast growth, so they're soft. They pop up really quickly, and then they die a lot sooner than a lot of trees. But in areas where you get big stands that end up kind of all dying together because they're roughly the same age, great place to find woodpeckers.
Yeah.
The rot just hosts so many insects for them to feed on.
When I think of quaking aspen and I compare it with, let's say, something like an eastern cottonwood, I think the leaves look very similar, but I think the quaking aspen has sort of pointy teeth on the leaves, whereas the cottonwood has more of a rounded.
rounded,
teeth.
and then the base of the cottonwood is very wide and.
Yes. Add a description to the big-tooth aspen.
More like oval-shaped and large but rounded teeth.
Okay. Oh, that's a cool tree.
So let's go look for some sycamores.
Where did Matt
We
go?
lost Matt. Matt, where'd you go?
All right. Well, if that didn't work, I don't know what's going to work.
Definitely didn't work. Well, gone forever. Just you and me now, Steve.
I guess so.
Witch hazel.
Yeah, we got another witch hazel. Oh, let's see. Oh, yeah, these are exploded seed pods.
Nice.
The ovules are still attached. They're still very noticeable without the petals.
Some of them even have petals.
Oh yeah, they do.
Really withered, but the petals are there.
It's still cool because they're still very colorful. Hey, look at that one. That one's like pretty much fresh.
Oh, that
It
is a
even
nice
still has
looking flower.
anthers in it.
Yeah. So the witch hazel actually has a really interesting flower. It has something called stamenoids. Stamenoid is basically a modified stamen. It has no pollen on it. It's just a sticky surface that is covered in sugars and whatnot. But they're sort of deep in the flower. Oh. And so it tricks insects into getting deep, and getting covered in pollen in order to get that reward.
So it's taking no chances at once.
Yeah, and it really is far in there.
Sure.
But I'm pretty sure you could see it. You don't have a hand lens on you?
I don't know.
Well, yeah, it is really hard to see.
Yeah, my eyes ain't what they used to be.
Yeah. All right. Time to see those sycamores. Well, we just came across an older beech that is really holding on to a ton of its leaves.
I like it because it's very obvious where most of the canopy is because all the branches are tilted on one side of the tree. Even some of them are kind of like coming out northwise and then bending towards the south.
Do you know what's interesting? Is that the leaves are really only on the lower 15 feet of this tree.
Again, where I think deer can get up on their hind legs and nibble in.
Right, so you think that all the upper branches aren't holding onto their leaves?
I mean, it could be, but it also could be that those are also the most exposed to the elements.
I was also thinking that too.
This is probably confirmation bias.
Oh, I know, but still, it's still an interesting thing to think of.
Yeah.
What'd you find?
I think what is one of the weirdest fungi I've seen on a young tree. Too young, actually, for me to tell what it is, but it looks like this tree has a 5 o'clock shadow.
It's stubbly. It looks like it's really mostly in the cracks of the tree.
So wherever there's a weak spot in the bark, there's this little black whisker. That's as best as I can describe it coming out.
So look above here where there isn't any cracks. It's just more smooth. It almost looks like the holes were maybe formed for the fungus or whatever it is.
This is the weirdest thing I've encountered.
Really cool.
That's so cool.
It legitimately looks like a 5 o'clock shadow.
Yeah. And it's all up. Wow. That is so strange. Gonna have to call in some of our fungus friends.
Yeah, I know.
The ones that don't shower enough and they're full of fungus.
Oh, no. Yeah. All right. Time to move on from this disgusting tree.
I'm offended.
What did we find?
We found a fern.
Dryopteris.
So this is an evergreen wood fern?
Without a doubt, a Dryopteris. So evergreen wood fern. It is once, twice,
I was going to say
thrice cut.
Seems like it's thrice cut. What else is thrice cut? New York fern. Thrice.
Yes, the Dipterus. I like the Dryopteris because it keeps any fern person from becoming too complacent.
What do you mean by that?
They hybridize a lot, and they're very hard to tell apart.
Hey, how good have you gotten with grasses?
You mean sedges?
Well, anything. Oh, this one's plantain-leaved, I think.
That's a plantain leaf sedge.
That's kind of cool. So those guys are evergreen.
I like it. One reason they're so ecologically important.
What uses them?
I think a lot of moths will lay their eggs at the base and leaf miners, such larvae.
Mm-hmm. This is a small one, though, because normally I see them and they're way bigger.
It's a highly disrupted environment because of mountain bikers.
Yeah. That's the one thing you almost always see, but not during the winter. So we have a hawthorn.
This is a hawthorn,
yes. Watch your eyes.
Yeah, it's very spiky. But there's a really great, I think it's a liverwort right here.
Yep, that is Radula. The genus Radula.
Round scale.
Yeah, very rounded, large, scaly leaflets.
Overlapping.
And they kind of have like a matte finish to them. They're not shiny. They're almost kind of like...
Is this that dull green one?
Yeah. Ow, 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 ow.
I warned you about the hawthorns.
Well, this is Japanese barberry.
Oh, yeah.
Terrible little invasive.
Berberis. Our native barberry is Mahonia. I don't think we have Mahonia around here.
East, that's a western.
Yeah, it's sort of a western genus.
This is Radula.
Okay.
Liverwort. And then Frulania, more Frulania as you go farther up.
So Frulania is the one we saw in the last tree. And are those patches also Frulania?
Yeah, so that's what I was talking about, those rings or circle patches.
Oof.
But
Yeah,
we also have
Yeah.
the moss Eulota, the genus Eulota, and I think there's 2 of the most commonly encountered species, and it all depends on the sporophytes, where they are oriented. So see how these come out past the gametophyte?
Yeah.
That is one species, and then the other one's got them, the sporophytes are tucked in. Don't know which is which, though.
You know what I saw on the path earlier? Bead fern, a.k.a. sensitive fern. Yeah. I just saw the reproductive part sticking out of the snow. And it's called bead fern because that's what it looks like. Sort of a bunch of beads on the end of a stalk.
Now we're walking down by this black willow here to our right, giant black willow. All along the side of the trunk are just young willow shoots coming
Yeah.
Epicormic buds.
So epicormic buds.
Right. Kind of like the stem cells of the plant world, so they can differentiate into any sort of tissue, and they lie dormant most of the time, but when something damages the tree, they can shoot out and become the apical bud, but the epicormic ones are oftentimes just offshoots that come off of the side of the tree, and this black willow's a great example of it. But you got to think of like what the black willow's adapted for, these riparian habitats where a lot of damage, a lot of disruption from flooding, and eventually, in these winter areas, ice scour. So they have to be able to withstand having their crowns broken off and snapping and kind of making up for lost time by throwing out a new dominant shoot. So
I like how Sarah's on a spot right now that looks like in the spring it's going to drop right off.
Yep.
Although she's right at the base of a tree, so maybe she'd be safe. You guys tried to do the
yeah, we did a live stake planting.
the live stakes.
I don't know if I see any.
No, most of the land where we planted them
Fell right in,
disappeared.
right?
Yeah.
Yeah. Oh, here's some oaks. Oh no, this is a maple. This is a red maple.
Yeah.
And it's holding on to a ton of its leaves.
I wonder if something bad happened here.
It's really covered in
what I would
lichens and
expect.
moss. But the tree itself looks
Pretty
pretty decent, yeah.
Yeah, just stressed or something.
It's not the only one. Right next to it's another red maple with a lot of its leaves. Interesting. I'd love to find out why. Look at this, though. I mean, there's
Yeah, there's actually quite a few of them, even back in the woods there.
in a single glance, like five
Right.
or six trees. Okay, I think we found the culprit of that purple bird dropping.
Yeah, we have Vitus, a grape.
Yep.
And I can attest to the fact that
Sweet?
Yeah, it's poisonous. No. Very
And Matt
sweet.
just dropped dead.
I'm going to spit it out just to be safe.
Yeah. But we're pretty sure.
Well, look at that. Look at the color.
Oh,
I just reenacted it with my spit, and that was just from licking the juices
So
on my
it's
hand.
pink in his hand, but when he spit it out, it was purple.
Yeah.
Very weird. What's making that happen?
What I like about grapes after the freeze hits is just how sweet they are.
The plant actually pumps them full of sugar because sugar will stop them from freezing, and so they become way sweeter.
Sugar is a great antifreeze.
Awesome. I'm glad we found that out.
Yeah, good job. Delicious, good job.
So, do you guys know, like, Murder of Crows?
Yeah.
What do you think they call dick sissels?
A cohort? I don't know.
I was thinking maybe it could be a sausage fest of dick sissels.
Can we call Audubon Society right now and make that official? Or
They're
Cornell? Get Cornell on the phone immediately. Excuse me.
What if it's a girth of dick?
Oh, no.
Oh, no. That's not the size of the flock. It's how you use it.
Oh, boy.
We've succeeded in our mission.
Yeah. So it's not a big stand.
But it's where you'd expect to find them, which is also kind of satisfying.
The sycamore has a really, really specific looking bark, especially when you look further up the tree. It has these big patches of greens and whites and brown bark.
Right.
There's a nice little poem. Does anyone want to?
I don't remember it, so it's all on you.
Look at this tree all covered in sores. If it doesn't get better soon, it'll be sycamore.
That's adorable. It gives the impression, though, that poem, that sycamores are sickly trees, but they're definitely...
Maybe if you thought of a
blotchy.
sycamore as a person,
Right.
kind of like a weird skin disease.
Right. I absolutely love sycamores, so they're this great riparian adapted species, really good at getting its feet wet.
One tree that can actually be confused with it is the London plane tree.
They're related, so...
They're closely related. One of the ways that I know to tell them apart is if they have the fruits growing on them. And the London plane tree, it's usually in pairs.
Correct.
The fruits are growing in pairs, whereas the sycamore usually has it growing in single fruits.
Yeah, and generally if you're in a more wild area like we are today, sycamores will just grow a lot taller. But I love sycamores because, A, they're just gorgeous trees. They get huge, and they're super adapted to disturbance. But I was really introduced to this group because of riparian restoration plantings with live stakes. So you can actually cut the dormant branches or epicormic shoots of these trees and put them into the ground while they're dormant, obviously. And if it's wet enough, they will grow roots and grow into a whole new tree. So it's this wonderful form of asexual reproduction that is really good if you live in an area where, again, ice scour and regular flooding can disrupt your life and send parts of you careening down the river. All you have to do is get wedged in the muddy banks, and suddenly a new colony has formed.
Yeah.
Do you have any guesses as to why the bark is so peely?
I have no idea, actually.
Sarah?
Maybe to help rid it of disease?
You're definitely on track with the ridding of something, but it's not disease.
Pests.
Is it pest?
Kind of. As you go down the tree, look at how much epiphytic growth there is of our friend the radula, mosses, lichens. The farther up, not as much, right? So this is one of those trees that has chlorophyll under its bark, so the greener patches will photosynthesize.
Right.
So extra means of producing energy. And if you get covered in epiphytes, that's where epiphytes cannot be so commensal. So by continuously sloughing off chunks of bark, you're shedding a lot of epiphytes and keeping your photosynthetic surface completely free.
As the tree gets larger, it might make sense, too, to keep the base of it somewhat armored.
Once its base is completely shaded out, it doesn't make sense to produce photosynthetic tissues.
Right.
So the antiqued bark is strikingly different than the younger bark.
These have retained a lot of their seeds, their fruit.
Yeah, they're really holding on. All right, guys, I think I'm going to end the episode in Buffalo, where one of Buffalo's oldest trees is the sycamore, and I think it's a really beautiful tree to talk about.
Tree.
I think I might end there, but do you guys have any last things you want to say before I sign out?
Great hike. Really nice to be back. Indefensiveplants.com. You can Google Indefensive Plants. We're on Facebook, Tumblr, Twitter, all the major social medias, and we're on iTunes, Stitcher, and all the major podcatchers. So check it out, Google it, and subscribe if you want to learn a lot about plants every week.
It's almost as good as the Field Guide.
Almost, but not as.
Yeah, it's a close second, but yeah. And Sarah?
From time to time, I have a blog that I post to called Midwest Explorer that you can find on Facebook and nowhere else. It used to be very bird-focused, and I realized that birds are very difficult to take photos of, and I take a lot of nice photos in our exploration of the Midwest, and so I've decided to expand it a little bit.
Well, it's a cool page, so check out Midwest Explorer and check out Indefensive Plants. Thank you very much for joining me.
Thank you for having me.
Thanks for having me on the podcast and hanging out.
All right. So as I just said, I'm currently standing next to Buffalo, New York's oldest tree. As for a quick description, the sycamore is about 12 feet in circumference at breast height. I don't really have measuring tape with me, but if this tree were perfectly circular, that would make it almost 4 feet in diameter. It's also reportedly about 65 feet tall. And as for the history of it, during National Forest Products Week, October 16th through 22nd, 1960, the Buffalo Lumber Exchange presented the tree with a plaque, making the claim that this sycamore tree is believed to be the oldest tree in Buffalo, about 250 years old. So like I said, I had some doubts about this, and I think I was somewhat justified. So this tree is not on the American Forest's Champion Tree National Register. And while they have a record for the Arizona and California sycamores, they don't even have a record for the American sycamore. So I continued on to monumentaltrees.com. This site's inventory only contains tree records as far as they're registered on the site, so it's definitely an incomplete list. So there's a chance that our tree here was just never registered. But let's quickly compare it to some of the other records. Their oldest sycamore entry is from France at currently between 237 and 297 years old. Second place through fourth place are all European trees between 297 and 189 years old. And in fifth place, we finally have a North American tree, and it's in Murfreesboro, Tennessee. And that tree is between 177 and 197 years old. So that's a lot younger than, what the tree here in Buffalo is claiming. The girth of that specific tree is about 17 feet at chest height and about 74 feet tall. So that's 5 feet more in circumference and about 10 feet taller than our tree in Buffalo, and it's supposedly over 100 years younger. Now, I know what you're thinking. A tree's height and girth don't necessarily tell us the age of the tree, and you'd be right. What I haven't told you about this tree is that it sits on a tiny patch of ground surrounded by cement on all sides. We have the sidewalk, Franklin Street, a path connecting the street to the sidewalk, and a driveway all surrounding the tree. So there's a chance that this tree has just had rough growing conditions, and it just didn't allow it to reach its full potential. And that would be a respectable opinion, but we won't really know until there's some type of official aging done. So I wish I could find more documentation about how the original dating process went back in 1960, but for now I'll give up. So I hope you guys enjoyed Matt and Sara on the podcast this week. Combined, they're only about a second-rate bill, but I thought they did pretty well. So make sure to check out the In Defense of Plants blog, podcast, and Facebook page, and make sure to like Midwest Explorer on Facebook. I would also like to thank our growing list of supporters on Patreon.com. Thank you so much, Diane, Ken, Scott, Matt, Beth, we named the dog Indy, Paul, Molly, Rob, Alyssa, Dan, Dave, Chimera, Kimberly, and Lee. We also received one more iTunes review since our last episode, so thank you Prairie Dog for the nice review. So keep those reviews coming, guys. It really helps us get the word out to more people. We have 18 written reviews right now, but we'd really like to get up to that arbitrary goal of 25. And Bill and I will do something when we finally get there. Bill and I would also like to give a huge shout out to Byron from To Know the Land on 93.3 FM CFRU out of the University of Guelph in Guelph, Ontario. We recently recorded an episode with him, and if all goes well, we'll be featured on at least his March 20th episode. His show is pretty great. It's about half music, and about half either him reading an essay, playing a recording, or doing an interview. It's really good fun. So in terms of the music, it's pretty great. At least I think so. It's been all new to me anyway. It's not really your typical radio in that regard. So before Bill and I appear on his show, check him out. His back catalog of episodes can be found on cfru.ca/recordings/315. And if you didn't catch that, don't worry, I'll put a link in the show notes. So if you have any of your own questions, comments, or episode suggestions, send us an email at thefieldguides@gmail.com. Visit us on Instagram at Field Guides Podcast. Follow us on Twitter at Field Guides Pod. Like and follow us on Facebook. Visit our website at thefieldguidespodcast.com. And support the podcast on patreon.com/thefieldguides. Thanks for listening, and we'll see you again later this month for episode 17.